So essentially, this animal level intelligence, let's put it that way, is what we describe it as nature inspired AI also at -0, right? What exactly is nature inspired AI, if you can elaborate it for our users? And also I would like to say, once you get to know about it, do check out our white paper where we have described in detail. So yeah, go for it.
I think before going into what nature-inspired AI is in its nitty-gritties, it's first very important to understand how we as humans have become so good drivers.
Okay.
We never learned driving in the first attempt.
Okay.
Neither do we learn very specialized tasks first.
Okay.
Instead, humans have built a generalized understanding of the world first.
Yeah.
And then over time, we become specialized at one task, whether it's specializing in the field of your study, like finance or engineering, or specializing towards driving or cooking like that. And having the generalized understanding first that we build during our, first few years of after human birth, that allows us to build those reasoning capabilities of knowing what is right and wrong, then use that to specialize towards any one task. Okay. So this is contrarian to how we have been approaching AI. Right now, every AI is very, very task specific. So we are stuck in something along the lines of Moravec's paradox, where AI is very good at specialized tasks, but it fails at these primitive tasks that even an animal is very easily able to do.
Okay.
So humans go from generalized understanding to specialized, where right now we have been presuming, let's build a lot of specialized models and eventually we might achieve this so-called AGI. That is what even foundational models try to divert away from.
So generalized understanding, as in, you're trying to say, as humans, we understand the obstacle. Let's say this is a cup. This is a table. We are sitting over here. This posture is called sitting. Is this what you mean by generalized understanding, or is it even more basic than that?
It's a 3-stage process of learning. Maybe I'll elaborate this a little further. We have something along the lines of a world model inside our head. Let's call it representation for namesake. Okay. Now, this model, or let's say module, has developed an inherent understanding of the world that is not limited to a specific task. It's not trying to do, let's say, detect certain obstacles or do one specific task like balancing. It has a very comprehensive understanding of the world that we have built over time from our first few years, when we try to understand, what exactly the threat is. Even we might not know what's its name. We know how to, avoid certain things, how things behave. So this world model essentially understands how the world behaves, why things are the way they are, why they follow certain set of rules, they are governed by certain set of rules. Now, we understand the physics, the context of the environment so well using that. Right? And then over time, we keep on building, we understand, this obstacle that we see is a cup. Now we know, this is black in color, right? Though we initially know, even when we didn't have that knowledge, we knew there was something that was there, right? You can see this example, when a baby is born, he doesn't really know what the things around him are yet. He first tries to perceive, what exactly the threat is that I do not have to collide. It might not know its name. Then with time, first it knows to perceive that, then it gets to know what exactly that is. This is built over time. Now that is not specific to driving. We didn't evolve a learning for a task of driving, right? That is the first process. The second, let's call it prediction, where you understand how the world is going to behave around you in, time space. It understands the multi-agent interactions. It understands the social cues, the social behavior of the things around it. Now, with that, it is able to reason the consequences of its own action, right? And it's able to predict, what the decision that I'm going to take is the right decision or a wrong decision, or what exactly it should do. It's as simple as, should I stop or not stop? Should I, let's say, I'll give you a simple example. Even if we do not know what are, let's say, the depth of something is, you cannot tell me, this is how many millimeters away from you. But we understand, if something is coming towards you, even if relatively, you start slowing down your pace. Now, whether it's driving, you slow down the speed, whether you're walking, you slow down, because you are quickly adapting itself that, I can potentially collide, I need to correct myself. You're predicting your consequences. Then the final layer, the final block of this process is adaptation, where the knowledge that you have developed in representation and prediction, you use that knowledge towards a specialized domain. Now, is it playing a GTA Vice City using 4 keys on the keyboard, or it's driving using a steering wheel and an acceleration pedal? They're both essentially same thing. The intelligence you use to do both these things are same, and even for other things, right? And this just doesn't end there. After taking a decision, you are constantly taking feedback from your senses of the environment around you, and then making a decision. If was your decision that you took was right or wrong. If it was wrong, you propagate those learnings back into your entire, let's say, the entire chain. Okay. And that you do in a purely self-supervised manner. And this is a cycle that we keep on following. Now, whether we were learning how to crawl, how to respond and perceive threats around, to learning driving. So now let's put it down. How did we become better at driving? During our first initial years, we tried to know what exactly the world is by learning to crawl, how to balance, right? How to perceive threats. Then over time, we started to have knowledge through, what exactly, what is a car? What is a steering wheel? It has an acceleration and a pedal. How other things around you look? There is a tree. We developed those layers of knowledge, right? And then finally, all it took was spending 1 week in a driving school to become a very good driver. And we have been keep on practicing that driving over and over to improve ourselves. Now you see that process of generalization to specialization.
Yeah. So interesting take. So essentially, you're trying to say is that the 1 week or the 1 month that we spend in a driving school is not when we actually learn to drive. We're actually just learning to adapt to a particular machine, which is like a vehicle to drive. But the inherent understanding of navigating the environment, of avoiding obstacles, is developed way in our early years than we actually perceive to be. But moving on, if we are able to build a kind of a generalized intelligence as we are talking about, and we are not talking about AGI. To be very specific over here, that we're talking about generalized intelligence, which is like an animal level intelligence, as you have been talking about, and using that intelligence to drive is essentially what we are talking about over here. Essentially, if we are able to build that, which again it's a gigantic problem statement to solve on the first place, but if we are able to attempt that in a phased manner that we are planning to do over here at -0, essentially we will solve most of the problems associated with autonomous vehicles as of they stand today. For example, we won't need to collect billions and billions of miles of driving data. We wouldn't have to map each and every city to a millimeter level of accuracy. We would not have to place hundreds of sensors on a single vehicle. We can actually adapt from one geography to the other. We can actually go from one vehicle form factor to the other. Let's say my AI system learned to drive on a sedan vehicle. It can very quickly adapt to a SUV vehicle. It can very quickly adapt to a truck, these long haul vehicles. So all in all, essentially, what we are trying to say over is that a base generalized understanding that essentially is what is required to build this. It can do all the tasks over all different scenarios, different adversarial scenarios, different form factors in different geographies, and still be able to do a lot more and be safe at the same point of time.
And that is actually the bigger part. We are not just talking about, it has to be more affordable or economic side of the thing. That is just an after effect of this. Even after solving the economic side, still it will be way more safer than what all current systems can do, because it will be able to handle the adversarial scenarios also very well. Because that is the ultimate goal. Humans are safe drivers, and they're still safer from all the robotics algorithms right now. That is exactly what we are aiming for.
So all these ultra high extensive sensors are essentially giving AVs the superhuman capabilities while it's still not being a human at the very first place.
So you're trying to be a superhuman while even a cat can outsmart you.
Interesting way to put that. So now as you know that building NIA, generalized understanding, is a wide enough problem statement. There are multiple sub-aspects to it. And that's why we like to call ourselves as an AI company first, because we are solving essentially these problems and then using that to apply to a driving related task.
Right.
So can you give some kind of examples of problem statement that we are trying to solve over here at -0, so that the users or the researchers who are coming new to the industry, or who have already been working in the industry could also think along on these problem statements, and we can come together as an ecosystem to solve these.
Okay. I think I'll put it in two ways. First, I'll give what exactly nature-inspired AI proposes. So think of this like similar to next generation of a set of foundational models.
Okay.
More inspired from human brain that transcend to beyond just vision and language modalities and the related ones, to induce decision making.
Yeah.
By using explainability, reasoning, and adaptability to them. Right now, in an attempt to solve those, there are certain different problem statements that we'll be solving alongside. I'll maybe name a handful. One, definitely we talked about having that world model, which is you're not trying to teach the specific task, but you're making the model understand how the world behaves, making it grasp the physics and the context of the scenarios. That is one thing that we have been extensively working on. Another one is how you can really learn navigation without having a prior understanding through a map, because as a human, we always work in a local frame of reference.
Correct.
Right? You do not have a map of entire HD map fed in your head, though you might have some memory of something if you have gone. But you can still drive on a new, let's say, city, even if you do not know anything about that. Maybe another one, I can let you know, right now you see reinforcement learning, it's always 0, 1, okay, I collide or I do not collide. These are handcrafted, policies. But the real challenge is how you can really make these policies evolve over time. Gradient policies, okay, when to focus on what, because you cannot learn driving on a road by, okay, if I collide, then I'll learn. No, it's that handling those nuances on the go, how much to learn, when to learn, and through, after paying attention to which thing you would be getting that insight. So this is non-exhaustive list, right?
Yeah.
There are multiple more along these lines we are solving.
Exactly. So, if these problem statements are something, which interest the new generation research work, I think it would be a great way to solve for the bigger problems of humanity that includes autonomous vehicles at the very first place.